morning. Welcome to lecture 52, Risk-Based Decision Making 2, under module 11, Prescriptive Safety Analytics. We will discuss in this lecture on risk prioritization, analytic hierarchy process. We give one example for AHP, how AHP we are using to prioritize the criteria, and then using expert opinion and historical data, we will show you that how the prioritization is made here. Okay. So here, if you go back to my last lecture, then you have seen that I have given you what are the checklist for decision, risk-based decision making, and there I told that prioritization is one of the important issue in this, and also I told you that you can prioritize the risk, prioritize the alternatives, prioritize means the actions. So here I will just show you that prioritization as well as comparison of risk of accident path or incident paths. So you can easily convert this to actions also. The procedure what I am discussing, that is applicable for prioritizing different risk management activities. You just first understand what is analytic hierarchy process. So this is a multi-criteria decision making tool, and in fact there are many other multi-criteria decision making tools developed over the years, but analytic hierarchy process is very popular, and once it developed in 1977, it has been under use in all domains of applications, be it business, be it marketing, safety, quality, reliability, supply chain, wherever you want to do, administration. So what is the basic principle behind analytic hierarchy process? That suppose I have several alternatives, and then and based on certain criteria and with reference to the objectives, where objective we will basically selecting the best alternatives, that is the objective. So how we can do? So essentially this leads to a tree structure, a hierarchic structure, where goal, that means what you want to achieve. Then if I say the goal is here prioritizing potential incident paths, then what are the alternatives? Alternatives will be definitely what are the different paths given to me. If my goal is that okay, prioritizing different safety measures, then the alternatives will be different safety measures. If my goal is to see that what are the maybe safety barriers, suppose you want to use different safety barriers, so and depending on the criteria you want to choose which barrier is most effective, then alternatives are different barriers. So that sense. Now what are the criteria? Criteria are something based on which the alternatives are chosen, whether best or not best. Okay, so depending on the goal, the criteria will be different. For our domain, the safety and risk analytics here, as we are interested here to see that which of the accident paths or potential incident paths, PIP means potential incident paths, which are the potential incident paths having the that maximum risk. Then using three parameters, probability, consequence and detectability, we want to find out this. So that's why we have created criteria, probability, consequence and detectability, PC and D, probability, consequence and detectability. It is very well used in failure mode and effect analysis, where RPN is computed based on P, C and D, but we are now saying that okay, for every alternative or potential incident path, there is a potential probability of failure, potential consequence, potential detectability. If I know, then based on this criteria, can I say that which path is more prominent? Alternative way, other way you can say that suppose if you think that okay, for a particular incident path I want to reduce the risk and I have several safety alternatives, in the sense safety barriers. So, k number of safety barriers are there. Then obviously, I want to choose which barrier is the best. Then the criteria will not be probability, consecutively. The criteria would be like this: the barrier effectiveness, barrier cost, barrier implementation potential, barrier maintenance. All those things will be the criteria. We will choose a barrier with maybe the lowest cost, or a trade-off between cost, reliability, maintainability, quality of the barrier, implementability of the barrier. So that way the criteria will be different. When you have a goal and you have set of alternatives with you, and you know what are the criteria important to choose the alternatives, then AHP is a very good tool and you can use it. What AHP does? AHP basically find out weighted, that means some weighted values for these alternatives. If it is risk, weighted risk for the different paths. If it is alternative related to safety barrier, then weighted risk reduction capabilities or of these safety barriers. So those things basically you will consider and you will use analytic hierarchy process. There are TOPSIs, there are fuzzy HP, fuzzy TOPSIs, that ANP, analytic network process. Then there is Vicar, and there are other also. So there are many multi-criteria decision making available, which you can use here, but AHP is probably very easy to understand and easy to implement. That's why we have chosen, because the purpose is here not to tell you that what is the complicated technique, rather to tell you how the prescription in the safety and risk analytics you will be doing, and that is the reason AHP is chosen for us. Now here our objective, as I said, that we will not use the AHP in the entire process, like up to alternative selection. Here we are going to use only to understand which prioritize the criteria. So that's why I put a dotted rectangle here. The reason actually we are interested, so this one, this is just a minute please, I am saying this one. So we want to use AHP to calculate the weight of each of the criteria for risk estimation, and rest then when I will select the alternatives of those things, that is the traditional way, which is having the highest risk value, that way we will rank it. But here for this particular lecture we are using AHP for this purpose only. Now what are the criteria? Probability, consequence and detectability we have taken. So, but AHP can be used for the entire process up to selection of alternatives. Also in that case, what will happen? The alternatives related information also required. Okay. So now let us see that how we are doing it. So in order to do this, we first let me explain okay, one thing, that sorry, this is my first part, then second is this. Okay. We are not using simple HP, we are using fuzzy HP, and I think you have already understood the fuzzy set concept, fuzzy number concept. Primarily trapezoidal fuzzy numbers we have used earlier also, and to keep in the parity with the earlier development, here also I will be using trapezoidal fuzzy number. Why fuzzy number we are using? Because the criteria, that comparison of the criteria, that we are basically doing using experts' opinion. When in the linguistic scale, when you, because criteria related data is usually not available in the safety and risk domain. So there we primarily focus on the experts' opinion, and when you are taking experts' opinion, we prefer to take in linguistic terms. When you are taking in linguistic terms, it is the better to use the fuzzy numbers concept or fuzzy sets concepts. So we have three criteria. So criteria one is our P and C and D. These three criteria we have chosen. Now, what we actually want to do, we will create a comparison matrix. So, develop pairwise comparison matrix. This matrix is known as A. Linguistic terms, bits of expert opinion. Okay, if there are more experts, so aggregate, you have to aggregate, but suppose for the time being, there is a scale, experts will give the comparative values, that which one is more important, which one is less important, something like this. I will show you in the next slide the criteria. First, you have to develop pairwise comparison matrix. Then second, from this pairwise comparison matrix, which you will be getting in the linguistic term, you have to convert the linguistic term into fuzzy, trapezoidal fuzzy number, fuzzy scale. You have seen earlier fuzzy scale we have used. So, when you are converting into trapezoidal number, so here only one, suppose it is basically equally important, because P cross P same thing, or and then this also equally important, this equally important. Suppose P with reference to D, suppose I can say some other important or something. I will show you the scale, exact scale I have to see. From there, you created a defuzzified, fuzzified 1, 2, 3. You convert all those things, that if it is equally important, all the 4 numbers will be 1 only. So, that way 4 A1 A2 means A1 A2, I am sorry, some disturbance here, getting some disturbance. Okay, so A1, A2, A3 and A4. Trapezoidal fuzzy number, we have seen that this is the 4 numbers. For every cell 4 numbers you create. Then after that you defuzzify it. Once you defuzzify it, you will create another matrix, suppose A dash, which is defuzzified matrix. Then you compute the eigenvalue of it. I will show you how to compute eigenvalue criteria. Now, with the defuzzified that pairwise comparison matrix, once you compute the eigenvalues, using the eigenvalues you will be able to compute the consistency ratio, because experts' opinion you are considering. So, whether the pairwise comparison they are consistent or not, that you have to check. So, that checking is, there is a formula, we will use it, and then the CR, if it is less than 0.1, the data will be consistent. Otherwise, you have to change the comparison matrix. The expert, the way it is given, it is not correct. Some changes are required. You consult the experts again and then get the revised data and do it. So, once it is consistent, then we will go for calculate the fuzzy weight for each of the criteria from A, and their fuzzy weight from the criteria, that P, C and D, these 3 criteria fuzzy weight we will compute, and then from their fuzzy weight we will again find out the Cripps weight for after defuzzification and normalization of this. AHP, this pairwise comparison and this calculation for the weight of the different criteria we are defining it. Otherwise you are taking equal weight whenever we are multiplying P into C into D, the general sense it will be equal weight, but we are saying they are not equal, means the impact of an accident and the probability of happening that accident, they are not equal weight, there is different weight. Okay, so that we are basically interested to discuss. Now, you see that how the things are happening here. So, previous slide I have given you all the steps. Now, I am giving you the simple mathematics. Don't get confused with the formulas. Looks like a big thing. No. These are all arithmetic only. So, first and foremost, as I told you, you have to create the comparison matrix in linguistic term. After that, you from the comparison matrix, you make it trapezoidal fuzzy number, fuzzy comparison matrix. Okay, pairwise fuzzy comparison matrix, which is A, where each of the element will be having 4 number of, each of the cell will be having in 4 elements, and when xij means the ith row and jth column entry is A1 ij, A2 ij, A3 ij and A4 ij, that's 4 trapezoidal that numbers. Now, if you just in the matrix, if you go the reverse side, that means jth row and ith column, when xij is the ith row and jth column entry, if it is this, then just the opposite, that reciprocal is that if jth row and ith column you go, then you are considering the reciprocal. That is basically in the trapezoidal fuzzy number, in the fuzzy scale, that is the way things will be done. And the way the pairwise comparison we are doing, the comparison of pairwise comparison matrix convert in the fuzzy scale, this is the way of conversions. First is fuzzy scale, every linguistic term in the trapezoidal fuzzy number you write like this. When you are going to the just the opposite, if xij cell to ji cell, then it will be the reciprocal of this, because this is the way the pairwise comparison is. If P versus C, if something, then C versus P will be the reciprocal of this. That is the way we are doing. Then as I told you, the next part is what? So from here, when you then convert this A to A dash. A dash is the defuzzified value, fuzzy to defuzzified. After that, you use A dash here and find out the eigenvalues, lambda are the eigenvalues. So, depending on the size of the matrix, that the rank of the matrix will talk about what will be the number of eigenvalues, and from those you consider the lambda max, the maximum eigenvalues. You find out the eigenvalues whose value is the maximum among all the eigenvalues extracted from using this equation, that is known as lambda max or maximum eigenvalue. Once you have the lambda max, then you can find out the consistency index using this formula, lambda max minus n by n minus, where n is basically, you know that what we are talking about, it is the n cross n is the size of the matrix, means square matrix, row and column equal length n. Now, so that means what you are doing? First, you are linguistic term, you are fuzzifying, fuzzy comparison matrix to defuzzified comparison matrix, then defuzzified comparison matrix is used to find out its eigenvalues. You take the maximum eigenvalue and that one you use to compute the consistency ratio. Once the consistency ratio is found, then this particular information will be used to understand the Ri. Okay, so what you basically required to do, you compute Ri. What is Ri? Basically that random inconsistency indices. So random inconsistency indices for n equal to 10, it is given here, and now you will find out depending on the size of n, you have to choose from this. So Ri, if you know the n, and then if you that we will find out, Ci you find out from the eigenvalues, and then consistency ratio Cr will be found out using this formula. If it is satisfied, you are happy with the pairwise comparison. Once you are happy with the pairwise comparisons, now you have to create the weight, calculation of weight of the criteria in A. In the A, you have the fuzzy numbers. So for A1, A2, A3, A4. So now for A1, A2, A3, A4, you are basically find out the geometric means. So these are the formula for geometric means. So that means you are getting weight for I, when I equal to maybe 1 to n. So that you are finding out, and j also 1 to n. So then after that, what you will find out is, so n number of alpha, n number of beta, n number of gamma and n number of delta you will be finding out. So, alpha for A1, beta for A2, gamma for A3, delta for A4 for the 4 fuzzy numbers, the trapezoidal scale you are considering. Then find out their sum. The sum we are denoting by alpha, beta, gamma and delta. Then after that you are finding out the weights. The weights formula is like this. So, for the first weight for alpha, so alpha I equal to 1 to n, alpha 1 by delta, alpha 2 by delta, alpha 3 by delta, like this. So, all the weights you are getting. Once you have the weights, so these weights again these are basically that A1 to A4. So, that sense you are using it. So, the equivalent, then again we are using again the general formula for depacification, and you find about 1 to 1 A1 with reference this alpha W1, and you have already created W1, W2, W3, something like this. So, what you do basically you use this formula again, and using this formula you defuzify. Okay, so this is the totality of fuzzy HP for creation of that weights for the what are the weights? Probability, severity, probability, consequence and detectability. Now, let us see how we are doing it with an example. Whatever I have explained, with the example it will be clear. A safety officer found out many potential incident paths which might occur in the workplace. He wanted to assess and prioritize the risk of all the potential incident paths. He considered 3 criteria: probability, consequence, and detectability for evaluating the PIPs. Further, he assumed that the 3 criteria have unequal importance. He decides to calculate weights by integrating fuzzy HP. So, I can say by using fuzzy HP, that will be better one. So, how you are doing it then? You have to first use the scale, SATI scale, and then move 2004 the scale is given. We are creating some linguistic variable equally important, weakly important, essentially important, very strongly important, absolutely important. And if you want to give some number to it, equally important means 1, weakly means 3. So, 1 to 9 point scale you are giving it if you are going for Cripps number, and then in between 2, 4, 6, 8 are the intermediate scale, which is between weakly important and equally important it will get 2, which is between weakly important and essentially important it will get 4, in this manner. So, then if I want to use the fuzzy trapezoidal fuzzy number, this Cripps conversion to this conversion to fuzzy is this. This is similar to one which you have seen earlier, but okay, definitely the values are different. So, what happen if it is weakly important, A1, A2, A3, A4 all will get 1. If it equally important, all will get 1. Weakly important, A1 will be 2, A2 will be 5 by 2, 7 by 2, 4. So, something like this, and in between values you can calculate using this formulation. Then you have asked the experts, they have given you this, they have given in this variables, linguistic variables. So, P equally important, same parameter. P versus C, we are seeing 1 by weakly important because it is the reciprocal of that. So, that means C is weakly important than P, then P is 1 by weakly important than C. So, that sense we have written here. Then P is essentially important than D. Similarly, C is equally important and C is very strongly important than D, and D is equally important. That way the scale matrix you found out. Now, this matrix, the one side we complete, other side will be just the reciprocal of this, and then you converted this to equivalent fuzzy. Okay, so that means converted to A. Now this conversion using this, all equal important, you see 1 1 1 1 1 1 1 1 1. Now the second one, that 1 by weekly important or weekly, then it will be weekly important. So weekly important, you see 2 5 by 2, 2 5 by 2, 7 by 2, 4. Then C will be 1 by AY, that means it will be 1 by 4. So this one will come, it is just other way, 1 by 4 max, one reciprocal of the maximum will be the minimum in other case. So that is why 1 by 4, then second one is 2 by 7, third one is 2 by 5, fourth one is 1 by 2. So that sense, this is the way that A matrix is created. But problem is that we will not be able to get the eigenvalue of this matrix. So we will not be able to find out the consistency ratio of this data, what is given there, particularly this to this. If we convert it into Cripps scale using 1 to 9, then you put these values, then that is the Cripps data, you can find a matrix, square matrix, eigenvalue you can compute. But when you are converting into fuzzy scale, that in each cell there are 4 values, you have to defuzify, then only you will be able to get the eigenvalues of it. So that also we have done. So what we have done now, you see, after that we use the defugified formula. This formula we used because see earlier we have used a different formula, but here we have used this defugification formula. Earlier we have given you, I think, center of gravity formula. Now in this kind of pairwise comparison case, this formula is extensively used. Definitely there are certain reasons, so those reasons you identify. So for the time being, whatever I understand that from the literature I found that this is the mostly used. Okay. So using this, so what you have created then in step 2, you created the defugified pairwise comparison matrix. Now here, now using A dash lambda equal to A dash y equal to lambda y, where y is the eigenvectors for this matrix and lambda is the eigenvalues. This is the characteristics equation. Using this relation matrix, that algebra, you will find out this using this, and we go for eigenvalue eigenvector decomposition. So eigenvalue eigenvector decomposition. What it will give you? It will give you the value of lambda and y. In fact, you will, depending here it is 3 cross 3 matrix, so you will get 3 lambda and obviously 3 y. 3 lambda is a scalar quantity and y will be a vector quantity. Now out of this 3 lambda, the maximum value, the largest eigenvalue, you got 3.09. So that is what we said. Basically, once you from this matrix, if you find out the consistency index, then you have to have the lambda max minus n by n minus 1. So lambda max is 3.090, n is 3, so minus n minus 1, so you are able to get Ci. See, Ci you are getting what? 0.0445. Now in this case, what is Ri? Your Ri, see, your n is 3, so Ri is 0.58, so put Ri equal to 0.58. Then Cr is this, consistency ratio Ci by Ri 0.077. But what is the requirement? It should be less than 0.1. Fb is little less than 0.1, so data consistent, experts opinion consistent. Now you can use this weight, use this matrix. So it is satisfied now. So fine, we will use this matrix. Now let us go. Then what is the step 3? So that means as the pairwise comparison matrix is consistent, so we now want to find out that what are the weights. So, for weights calculation, as I shown you earlier, that we will be using the geometric mean. So, geometric mean we have used, and from this is the we have used the matrix called A matrix, which is fuzzy trapezoidal pairwise comparison matrix. From there, using the geometric mean, you found out all the values, that alpha, beta, gamma and delta, alpha I, beta I, gamma I, delta I, then alpha, beta, gamma, delta, which is the sum of things. So, now see that we have made the sum, we got this. So, this is giving you alpha I, beta I, gamma I and delta I, and this sum giving you alpha, beta, gamma, delta, and then after that you want weights. These weights are like this. So, here the fuzzy weights you are computing. So, alpha I by delta. So, what is the alpha I value? First one is actually alpha I by delta, that 4 points PCD 1 by 3.564, you will get this value, then 2 by this you will get this value, then this by this you will get this value. Okay, so ultimately using this formula you are getting these weights. So, from here if you want to get the Cripps weight, so that means the fuzzy weight to Cripps weight, the defuzzification, and then you are getting this Cripps weight. So, I have shown you how the defuzzification formula, and then now you see that the weight should be normalized because the sum of weights should be 1. So, up to make the sum of weights 1, so the normalized one is like this, that point. So, you take this sum, divide this sum with everyone. So, you will get this value 0.283, 0.645 and 0.072. These are the 3 weights. So, this is now this is what is the decision making decision now. The weight of the criteria is identified. So, P equal to 0.283, C is 0.64, means each of the criteria are not same. That is important one, because depending on the situation, severity may be somewhere, some situation severity obviously have higher values. So, that way we are basically looking into. Now, with this weight, you can now go for ranking. How do you rank this? So, fine, let there are 10 accident paths, or I will be happy to use the term called potential incident path, because I have told you earlier potential incident path. So, 10 potential incident path PIPs. So, PIP1, PIP2, PIP3, PIP4, PIP5, like this. Okay. So, 10 potential, this also you change accordingly, you write potential incident path. Now, potential incident path, suppose you have basically collected data in the linguistic form, then again you can, this particular part I have shown you earlier. So, you can now convert into this each of the criteria into fuzzy numbers. The weights are calculated using pairwise comparisons matrix given by just in the last slide we have given you. So, here we have used that motion and phase scale from this probability as well as consequent activity point of view. Beforehand what you have seen, this is not the for individual that linguistic responses from the C point of view, P point of, D point of view. No, earlier it was pairwise comparison, which one is more important, less important kind of things. Don't get confused with the two. Okay, so after that what will happen? So now I have what? I have the criteria values from the pairwise comparison matrix. The criteria values are there. Now for all the incident paths, all the potential incident paths, PI, all the potential incident path, I have this fuzzy that trapezoidal fuzzy values, and then I have the weights for all of the cases, the trapezoidal weights, and then what I will do, I will multiply these weights with the path probability P, C and D, and then this multiplied by this will result into this fuzzy number. Now again this fuzzy number, trapezoidal fuzzy number, if you want to compare, it will be difficult for you to compare. You have to convert into Cripps number using the formula already shown to you earlier. So using this formula you do it. Now what you are finding out? You are finding out that this is the Cripps weights. So Cripps risk values for each of the PIPs, you are getting it. Now what you will do? You just normalize it. So you normalize using this, because why 100 I have multiplied, because this will give you a clear cut differentiation, that otherwise if you take 0 to 1 scale, that you find out the low difference. So that means from the human that perception point of view, it is better to multiply by 100. Then you see what way we have done. We have simply taken the maximum one in the denominator. So here AP9 is maximum. So maximum by maximum 1 into 100. So its score is 100 with reference to the maximum risk item or risk path. We compare these the values. Now this is, there is a vast difference, 100, here it is 13. So you can feel that yes, I will first improve upon AP9, okay, and its rank is 1. But again if you go by rank here, you see that 1 to 10, so you may not get the huge difference what is there in this 100 scale. Depending on the situation, you have to go for 100 scale, point scale, or 10 point scale, or 1 within 1, 0 to 1, that you have to decide. But here the decision is that which accident or incident path, when potential incident path becomes actually realizes, that is the incident path, actual incident path, where you will concentrate first. That decision means that AP9. Then what is the second one? Second one is AP10. Now what is the third one? Third one is AP3. Suppose I don't have enough budget for attacking all those paths. So where to attack? AP9 to be attacked first. So this kind of decision are important, and now you can extend this further. Suppose for AP9, in order to reduce the risk of AP9, or I can say PIP9, that is better, PIP9, then what you actually do, you suppose you have many measures. If you go by hazard control hierarchy like elimination, substitution, that way also you can think, or you may go think in terms of the safety barriers, what is needed there. So then if you go by safety barrier, then it will be process variable in the sense actual implementation level, what are you going to do, that you know. So suppose you have 3-4 combinations, which combination you take, again you can go for similar kind of analysis to choose which combination of barriers will be chosen. Okay, so that is another kind of decision making. So that means that decision is nothing but decision related to selection of alternatives. This decision is decision related to where to concentrate, which potential incident path to be attacked first. So these are the decisions you have to do this. Now suppose in case, now forget about the previous one, except the Cripps weights, the defuzzified weights what you got. Suppose you have historical data, and when historical data is there, I am saying incident path or accident path. Okay, so incident path or accident path, whatever you want to use it here. So accident/incident path. So when this you have done, but now what else? Actually, suppose you have accident data, have already the path, the past few years records are there, and the accident path probability, severity and consequence, those values basically you somehow you have quantified, and but you want to give some this weights you quantified using the methods earlier we have discussed in this lecture, and then you want to see that which path is more rank wise. Now AP6, then AP10, I think AP3 and AP10 these are coming. Although there is no relation between my earlier example as this example as far as development is concerned, but if you want to find out relation, suppose that actually happened, you have done before any accident happened and you found out that accident 9, PIP 9 is more prominent, then PIP 10, and then if I go back, I will just let me see, if I go back I can get a relation. That means PIP 9, then your PIP 10 and PIP 5. So, that means what happened actually, based on this you taken actions and then you are happy that things, but in the process you basically did not concentrate on some of the incident path, maybe you neglected, and that maybe when you actually collected the data and you found out that this is the path, that means AP6 was neglected, AP6 was having 9th, because why you were neglected? Because its the potential risk value was very low. So, and then ultimately what happened, because of that complacency, that difference has taken place. So, this way also you can think, but again I am telling you the data is hypothetical data we have created to explain the concepts, utility, usefulness of these approaches from the prescription point of view. Okay. So, I am sure that you got a good amount of inputs related to decision making, particularly when you are thinking that your data is not that good that you will rely only on the records, a mixture of data when you are using, and when you are thinking that the criteria considered for risk are different in terms of their importance. So, obviously, you have to look into this manner. Okay. So, we have discussed some good things now, and ultimately this is the references, and you follow these references if you want to learn more. And thank you very much for your hearing, patience and kind listening to my lecture. Thank you so much.